What's up, pre-calculus students? I'm going to do one preview of this Unit 3 additional practice problems. Now, if you take this, you might see different questions in different order, but I'll try to go through them in order. Let's see if I can make them so that they are not randomized. Yeah, I'm going to make it not randomized. So you should have questions that are similar in the same order. Obviously, for your test, things will be randomized, so you got to be able to switch your brain into the right mode for the different questions. All right, here we go. Doesn't want me to start it. Let's see what we got. All right. So, always the first attempt whenever you see some equation that you want to solve is to isolate the trig function. This one is easily done by subtracting the 3 from both sides, and you get sine x equals 1. This is a unit circle problem. Sine being the y distance, the vertical distance, when's that equal to 1, straight up and down. So my answer is pi over 2. Those are the only answers between 0 and 2 pi. If I wanted to put it in the form of like all possible answers, I would say it's pi over 2 plus multiples of 2 pi n. So that I can go around the circle, get back to where I am, just different angle, same location. All right, so that's number 1. Yeah, this is the same deal. Let's isolate the trig function. I'm going to subtract 5, divide by 12. Negative 6/12 is the same as negative 1/2. Now, what do? How did I teach it? I taught that you got to find the correct triangle. You know, whether it's your short 30, 60, 90 triangle. Oof, I'll get it this time. Your short 30, 60, 90 triangle. There it is. Or your tall 30, 60, 90 triangle, or your 45, 45, 90 triangle. Oh, I just missed. Or your tall, or your regular 45, 45, 90 triangle. So here's my tall. And then you got your 45, 45. Oh, come on. So these are at the pi over 6s, the short ones. That's a 30-degree reference angle. These are at the pi over 3s, which is a 60-degree reference angle. You got a shorter side, a longer side. The shorter side's 1/2, the longer side's root 3 over 2. Okay, sine is the opposite over the hypotenuse. Opposite is 1/2 on the shorter 30, 60, 90 triangles. And then I use the acronym ASTC to figure out when is sine going to be negative. Sine's positive in the first and second because I'm going up. Sine's going to be negative in the third and fourth because I'm going down. So I want the pi over 6 here and here. Okay, so that's what I'm thinking. The pi over 6s in the third and fourth quadrants. How do I do it? 6 pi over 6 plus, counterclockwise is adding. So that's 7 pi over 6, 12 pi over 6 minus. So that's 11 pi over 6. So I want 7 pi over 6 and 11 pi over 6. Okay. Similar, we want to get the trig function by itself. So to do that, I'm going to square root. Give me secant x equals plus or minus, because I'm using a square root to solve an equation, square root of 4/3. Now I can simplify this square root of 4/3 to be 2 over root 3. I'm going to leave it like that. I'm going to leave it like that because I'm asking you about secant. Secant is the reciprocal of cosine. It's the flip of cosine. So if I flip secant to cosine, I flip this fraction. Okay, you don't flip the sign. It's just the fraction. Okay. So now the question is, when is cosine positive or negative root 3 over 2? We are again thinking about our shorter 30, 60, 90 triangle. This time the adjacent is root 3 over 2. That's what I want. Cosine's the adjacent over the hypotenuse. Hypotenuse is 1. So I want the pi over 6's when cosine is positive or negative root 3 over 2. Let's just work on like 2 at a time. Positive root 3 over 2 would be to the right, so here and here. So that's pi over 6 and 11 pi over 6. Negative root 3 over 2 would be here and here. So it's really all of the pi over 6's. So 1 pi over 6, 6 pi over 6, 5 pi over 6, 6 pi over 6, 7 pi over 6, 12 pi over 6, 11 pi over 6. Okay. Now, if you have two cosines, like here we got a cosine squared and a cosine, if you have two trig functions, we can't just isolate one of them. Okay, so we need a different approach. Approaches we should be thinking of are factoring, are to use our trig identities to help us rewrite and then potentially factor. Those are our techniques. Since these are both cosines, I'm going to look to factor. Now, to help me factor, I'm going to rewrite this with x's. So instead of cosine, I just have like x or y or whatever. And it's like, okay, I know these three terms can be written as the product of two binomials, two things times two things. I know I have 2x and x. I know I have to have a positive 1 and a positive 1. And then I'm like, is this correct? I want to check this. Well, it's like you can distribute a check. 2x times x is 2x squared. 2x times 1 is 2x. 1 times x is 1x. 2x plus 1x is 3x. That's good. 1 times 1 is 1. So that's good. I will rewrite 2 cos squared x plus 3 cos x plus 1 as 2 cos x plus 1 times cos x plus 1, and that equals 0. A product set equal to 0, as long as each individual piece of the product equals 0, we'll have solutions. So I have two equations from that. This equal to 0 and this equal to 0. So both of them I will isolate the trig function by subtracting and dividing. Here I'm just going to subtract. And now I have this situation. One is cosine negative a half and one is cosine negative 1. Let's start with the negative a half part. I'm thinking about my tall 30, 60, 90 triangle, 60-degree triangle, which occurs at the pi over 3's, because the adjacent side is 1/2. Okay, so cosine being adjacent. Now, when is cosine negative? It's in the second and the third quadrant. It's positive in the first and the fourth because you're going to the right, negative in the second and third because you're going to the left. So I want the pi over 3 in the second and a pi over 3 in the third quadrant. So 3 pi over 3, this would be 2 pi over 3. 3 pi over 3, this is 4 pi over 3. When is cosine negative 1? Well, that's when we just go straight to the left, and my adjacent side, my horizontal side, is negative 1. So that's going to be a pi. So I have those three solutions that I need to click. 2 pi over 3, 4 pi over 3, pi. Okay. Look at this. I get intimidated, but then I realize, well, there's just one tangent. So let's try to get it by itself. All right, well, let's get rid of this root 3 in the denominator first. I'm going to multiply both sides by root 3. Give me 3 tan x plus root 3 equals 2 root 3. Okay, well, now what do? Well, I can subtract then divide by this root 3 and then divide by this 3. So when I subtract root 3, it's important to do this. Think of this as 2x's minus an x. What do? You get 1x. So if I have 2 root 3's and I subtract 1 root 3, I just have 1 root 3 left over. 1 root 3. Don't need to write the 1. And then I could divide by 3. Tan x equals root 3 over 3. Now, tangents are tricky because I don't have tangents memorized. I have to just kind of figure it out. I know it's going to be two options. It's either the 30, 60, 90 triangle that's tall or short. I know it's not the 45, 45 because the tangent would be 1 because you have root 2 over 2 divided by root 2 over 2. Tangent being opposite over adjacent. So it's like, which one of these will give me root 3 over 3? If I go opposite over adjacent, or if I go opposite over adjacent, where this is 1/2 and this is root 3 over 2. I kind of know right off the bat that it's going to be this one. Why? I know if I take root 3 over 2 divided by 1/2, it'll just be root 3 because the 2's will cancel. Divided by 1/2 is the same as multiplying by 2. So that gives me root 3, but I want root 3 over 3. So if I take this opposite over adjacent, I get 1/2 times 2 over root 3, which turns into 1 over root 3, which then rationalized turns into root 3 over 3. So pi over 6's win. We need the pi over 6's when tangent are positive. ASTC. Tangent is positive in the first and the third quadrant. So I want this pi over 6 and I want this pi over 6. So 1 pi over 6 and then 6 pi over 6, 7 pi over 6. 1 pi over 6, 7 pi over 6. I only have one sine, so let's try to isolate it. Now it's sine squared, but let's see what happens. Divide by -4, I get sine squared x equals positive 3/4. The negatives cancel. Square root. Since I'm using a square root to solve an equation, I have a plus or minus. I'm working ahead in my brain. Square root of 3 over 4 simplifies to be root 3 over 2. You can square root the top and the bottom. Fractions to powers. So when does sine equal positive or negative root 3 over 2? Well, the tall 30, 60, 90 triangle, the opposite is the root 3 over 2. This occurs at the pi over 3's. I want every single pi over 3 because sine is positive here and here. So it'll be negative root 3 over 2 here and here at these two pi over 3. So it's 1 pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3, 5 pi over 3. 1 pi over 3, 2 pi over 3, 4 pi over 3, 5 pi over 3. Okay, great question. Now, there's stuff inside the trig function. A lot of people want to divide, but you can't. Okay, like I'm not allowed to do this because it uh, negates like order of operation rules. We'd have to get rid of the cosine first. So how do we deal with this? Well, we try to like almost like pretend it's not there, and we're like, let's think of what are the angles where cosine equals a half. Again, this is the tall 30, 60, 90 triangle because the adjacent is the shorter side. Cosine's positive in the first and the fourth quadrant. So I want the pi over 3 here and the pi over 3 here. That's the tall 30, 60, 90 triangle. So I'm thinking my angle that I want is pi over 3. This is 6 pi over 3, 5 pi over 3. And then all multiples of those around the circle. So if I go around the circle, I add 2 pi, I get back here, it's like 7 pi over 3. That's just pi over 3 plus 2 pi. So these plus 2 pi n are my angles. But those are not my solutions. Because I don't have theta inside here, I have 3x. So you can either just like keep 3x and say 3x equals, or you can like replace it and then re-replace it. It's up to you. But we get this, which means my solutions, x, are these divided by 3. Now, dividing by 3 is the same as multiplying by 1/3. I'm going to multiply all of these by 1/3, giving me my solutions are pi over 9, 5 pi over 9, plus multiples of 2 pi over 3n. Those are going to be all my solutions. So pi over 9, 5 pi over 9, plus 2/3 pi n. Okay, there's my fraction, no decimals. Now we have a situation where I have different trig functions. I can't factor this like I did the one before when I had cosine squared and cosine. I have secant squareds and I have tangents. It's like, what do I do? This is when we need our identities to help us. We need to rewrite this. I'm going to use my friend sine squared plus cosine squared equals 1, which is the Pythagorean theorem in our unit circle. Sine's the y distance, cosine's the x distance, the hypotenuse is 1. Okay? Now, I have secant squared here. I'm going to be able to replace secant squared here with tangents if I manipulate this correctly and then figure out what secant squared is equal to. So I start with this and I'm like, well, how do I get secant squared out of sine squared plus cosine squared equals 1? Well, I know secant's the reciprocal of cosine, so watch this. If I divide everything by cosine squared, you got to divide both of these. So I'm dividing sine squared and dividing cosine squared. Now, sine squared over cosine squared is tangent squared. Cosine squared over cosine squared is 1. 1 over cosine squared is secant squared. Ta-da! I now know what secant squared is equal to, and it's equivalent to a version of tangent squared. So I'm going to take secant squared, replace it with tangent squared plus 1. That's that. I still have the plus tan x minus 1 equals 0. Okay? Now let's look at what I can do. Well, I have a plus 1 and a minus 1, so I'm going to get rid of that. Now I still have multiple trig functions, which means even though I've simplified, I'm going to need to factor this. It's not a trinomial, it's a binomial. I could factor out the greatest common factor, a tan x from both of these terms. Divide a tan x out of tan squared, I have a tan x left over. Divide tan x out of tan x, I have a 1. Giving me two equations because I have a product equal to 0. The first piece equal to 0 and the second piece equal to 0. Tangents, opposite over adjacent. I need opposite to be 0 and adjacent to be a number. I don't want opposite over adjacent to be like 1 over 0. I don't want to divide by 0. So I need the y's to be 0 and the x's to be 1 or negative 1. So that's going to be here. That's at 0, pi, 2 pi. We don't want to include 2 pi. We're just going to include 0 and pi. 2 pi is not an option. Here I'm going to isolate tan x by subtracting 1. Tangents equal to 1 at the 45s. Tangent is negative in the second and the fourth quadrant. So I want the 45s, which are the pi over 4s, in the second and the fourth quadrant. 4 pi over 4, this would be 3 pi over 4. 8 pi over 4, this would be 7 pi over 4. So 0, pi, 3 pi over 4, 7 pi over 4. It's a good problem. Okay. Cosine equals sine x minus 1. What are our techniques? Well, we can think, oh, I gotta rewrite it using my Pythagorean theorem identity, sine squared plus cosine squared equals 1. But here's the problem. I don't have cosine squared. I don't have sine squared. I need squareds to help, to rewrite something in terms of something else. So, for this problem, and potentially others, a technique you need to be ready for is to square both sides. Now, when we square both sides, we might end up with more solutions than what actually work. We're going to talk about that when we get to the end. Now, the left side, easy. Cos squared is cos squared. The right side, people make mistakes on because they think it's just sine squared plus 1 or sine squared minus 1. But when in doubt, and you guys should always have doubts because you're high school students and you have no, you know, you don't practice stuff enough. So you should have doubts. So since you have doubts, write it out. This is sine minus 1 squared. Sine minus 1 times sine minus 1. Sine x times sine x gives us sine squared x. Sine x times negative 1 is negative 1 sine x. Negative 1 times sine x is negative 1 sine x. Negative 1 times negative 1 is positive 1, which means sine x minus 1 squared is actually sine squared x minus 2 sine x's plus 1. I add these negative 1 sine x's. Great. But now, Mr. Messner, I still have cosines and sines. What do I do now? Now we are ready to use my friend. Sine squared plus cosine squared equals 1. I have a bunch of sines. Let's just get rid of this cosine. Rewrite it in terms of sine. But how do I do this? Now, this is very important. You need to manipulate this algebraically. We divided in the last problem. In this problem, to get cosine squared by itself, I need to subtract sine squared, giving me cosine squared equals 1 minus sine squared. And that's what happens. This turns into 1 minus sine squared. Okay, now what do? Get everything onto one side. Let's try to factor. Subtract a 1, add a sine squared. Subtract my 1, add a sine squared. 0 equals 2 sine squared x's minus 2 sine x. The 1s are gone. Nice. Now I have something set equal to 0, and this something can be factored. It's up to you whether you want to pull out just sine x, whether you want to pull out 2 and sine x. You're going to get the same answers regardless. I'm going to just pull out a sine x and see what happens. I get 2 sine x minus 2 if that happens. Okay. Now I have a product. See when each individual piece of the product equals 0, sine x equals 0, or 2 sine x minus 2 equals 0. Now over here, I'm going to add 2 divided by 2. This turns into sine x equals positive 1. All right. One is sine 0, one is sine 1. Sine is 0 at 0, pi, 2 pi. Sine is 1 at pi over 2. So my solutions are 0, pi, and pi over 2. But since I squared, one of these might not work. Maybe 2 of them don't work. I have to check. How do you check? You go back to your original equation. You plug in your answers and make sure they work. If I plug in 0, cosine of 0 is 1. The sine of 0 is 0. 1 equals 0 minus 1. Okay, that doesn't work. 0 actually doesn't work. Cos 0 equals sine 0 minus 1. 1 equals negative 1. No, that's what we call an extraneous, a false solution. Let's check pi. Cos pi equals sine pi minus 1. Cos pi is negative 1. Oh, that's good. Sine pi is 0. Negative 1 equals negative 1. That does work. Pi works. Let's check pi over 2. Cos pi over 2 equals sine pi over 2 minus 1. Cos of pi over 2 is 0. Sine of pi over 2 is 1. 1 minus 1 is 0. That works. So 0 doesn't work, but pi and pi over 2 do. That's all the work that has to go into that one problem. It's a lot, which means like you got to be proficient. And if you make any mistakes along the way, whether the squaring, the manipulating, the substitution, the solving, you're not going to get the right answer. Okay, so be diligent, show a lot of work, don't make mistakes. All right, this is a calculator question. You will have a calculator portion of the test and a non-calculator portion of the test. So be ready for that. Don't think that the previous problems we did, you can kind of like guess and check using your calculator. Tangent equal to this positive 1.683. I'm going to get out my calculator to show you how to do this. Now, to solve for x, we can use our unit circle knowledge, find the angles, but like since this is a decimal, I don't know when tangent is 1.683. So then what I have to do is use an inverse. I'll use the inverse tangent, and I'll take the inverse tangent of both sides, giving me x equals the tan inverse of 1.683. Now, this is not multiplication, it's like the tangent of. So I didn't like multiply both sides by tan inverse, I'm taking the tan inverse of both sides. And now in my calculator, making sure I understand, we're in radians right now. So 0 to 2 pi means radians. Make sure my mode is in radians. We might have to flop between modes. So be ready. And I'll take the tan inverse of 1.683. Okay, 1.034. Now, here's the deal, guys. Where is that? Well, in terms of radians, we know where 0 is. We know where pi is. Pi is a decimal of 3.14. What's pi over 2? Pi over 2. 1.57. So 1.57 is right here. So 1.683, that's got to be right here. Somewhere right there. I don't like that. What just happened? Oh, 1.03. Gosh, my bad. Good. I'm glad I realized I didn't like that. Why didn't I like that? Why didn't I like that angle there? Tangent's positive. I know tangent's positive here and here. So I know my first angle, 1.57, that's got to be, uh, 1.03. That's like right here in the first quadrant. But here's the deal. Find all of the values from 0 to 2 pi. We know there's got to be another angle right here, okay, where the tangent of that angle is also equal to 1.683. Now, with tangents, all of the solutions can be found easily because tangent's always going to be kind of like opposite in our unit circle. It's always going to be a pi distance away. So I could take this solution, add pi to it, and get another solution, 4.176. I know this is in the third quadrant because that's when tangent's going to be positive. I could double check, like what would be 3 pi over 2 as a decimal? 3 pi over 2 is 4.71. Okay, so yeah, I'm between 3.14 and 4.71, so that's good. Okay, so let's double check. Like if I took the tangent of this number, am I going to get 1.683? Whoops. If I took the tangent of this number, am I going to get 1.683? Yeah. So that's why I have two solutions here. I have the 4.17 as well as the 1.03. Now, a little bit of test taking strategies. Ready? You have four options. You have one equation. Plug all of them in. Find which ones work. Good way to double check. Does the tangent of 4.176 give me something close to 1.683? Yeah, close enough. 1.682. Obviously, this is not enough decimals because it's rounded. Does the tangent of 0.841 give me 1.683? Yeah, no, it's not even close. It's 1.11. Does the tangent of 1.035 give me 1.683? Yeah, close enough. Okay, we rounded. Does the tangent of 3.982 give me 1.683? No. Okay. So test taking strategies, maybe look to utilize your calculator to help you. All right, this is probably a non-calculator problem. Sine, cosine, sine, 80 degrees, 20 degrees. What is going on here? Well, you will be given these formulas on your test, which is the sum formula, sine of a plus b, the cosine formula, okay? And I'm going to just stop at the sine formula because the sine formula, the sum formula, is sine of a plus b is sine a cos b plus minus cos a sine b. So it's sine, cosine, cosine, sine. Now here's the thing. I see a minus. So I have a minus. All right. A looks like it's 80 degrees. B is 20 degrees. Which means I can write this statement, sine 80 cos 20 minus cos 80 sine 20, as sine 80 minus 20. Sine 80 minus 20, that's just sine 60. What's the sine of 60 degrees? I know that, 60 degrees. Sine root 3 over 2. Boom. Okay? You don't have a calculator to do this. You can't just type stuff in. You use your formula to help lead you in the right direction. Okay. 19 pi over 12, the tangent of it. Now, these answers, a lot of them could be right. What do we do here? Well, we're going to have to use our tangent sum formula. Tan A plus B equals tan A plus tan B over 1 minus tan A tan B. I got to figure out what two angles add to be 19 pi over 12. Well, like you're going to use your pi over 12s that simplify. Like 2 pi over 12, can I add that to 17 pi over 12? I can't simplify 17 pi over 12, so I'm going to kind of skip that. 3 pi over 12 can be simplified. So 6, oh, hold on. 3 and 16 both simplify. 3 plus 16 gives me 19. 3 pi over 12 is divide the top and bottom by 3. It's pi over 4. 16 pi over 12, divide the top and bottom by 4. This I'm dividing by 3. Sorry, divide by 3. Pi over 4. Divide by 4. 4 pi over 3. So, turns out you can rewrite it like this. Tangent of pi over 4 plus 4 pi over 3 is the same as tangent 9 pi over 12. 3 pi over 12 plus 6. And you just got to keep working through like different pi's over 12 that do simplify, that turn into angles that you know the tangent of. Okay, so I need to fill in my formula. It's like the tangent of pi over 4, tangent of 4 pi over 3, pi over 4, 4 pi over 3. It's messy, but you get it. Now, what's the tangent of 4 pi over 3? Well, let's think about the tangent of pi over 3. So opposite over adjacent, root 3 over 2 divided by 1/2. That's going to be just root 3. It's root 3 over 2 times 2 over 1, which is just root 3. Okay? So the tangents of 4 pi over 3 is just root 3. The tangent of pi over 4 is 1, root 2 over 2 over root 2 over 2. Okay? But I'm being careful. I just did pi over 3. If I was at 4 pi over 3, let's see. 1, 2, 3 pi over 3, 4. Okay, that's good. 4 pi over 3, if I did it correctly, I would make sure I had a negative and a negative, which still would be a positive root 3. This is important. Okay, so now I can fill it in, making sure like, okay, I had the signs correct. I probably should have gone straight to 4 pi over 3, but whatever. Tangent of pi over 4 is 1. Tangent of 4 pi over 3 is root 3. Tangent of pi over 4 is 1. 4 pi over 3 is root 3. I'm hoping this solution shows up. If it doesn't, that's a bummer. I'm going to have to find 2 more angles and like redo the whole question. But let's see. 1 plus root 3, 1 minus root 3. Yeah, that's my answer. If you use 2 different angles, you might get something different. And if that happens, you might have to start over and find 2 different angles. Because like we saw in class, depending on the angle selection that you have, you might end up with like 3 over root 3 and 3 over root 3 in this one here and this one here, which means you'd have to then simplify, and then you would have these 3's. And I mean, I should check because maybe one of these solutions on the bottom is actually also right. 1 plus root 3 over 1 minus root 3. Okay, let's try 3 minus, no, I don't want to try that one. I'm going to try the 3 plus root 3 first. Parentheses. No, this is going to be a positive one. It's close, but it's not right. So this one is negative. Both of these are going to be positive. Anyways, just be careful, okay? Hopefully you pick the right two angles to start with. Okay, this is another one of those like, hey, rewrite and then figure out. They don't want you to figure out, which is nice. It's just like rewrite. So this is going to use our cosine formula. Cosine A plus minus B. And you probably know this one by now. It's cosine, cosine, sine, sine. With the signs flipped. Signs as in the plus or minus, so that's a minus plus. A, B, A, B. It looks like I have a minus here, and I have 103 and 54 here. Since I have a minus here, I have a plus here. So I can rewrite this as cosine 103 plus 54, and that will give me this expression here. And then 103 plus 54 is 157, cosine of 157. If this was a calculator question, type this into your calculator in degree mode, type that into your calculator in degree mode, and you got the same value. I don't think it will be a calculator question. Switch your mode to degree, type it in, type that in. Probably not going to be a calculator question. Tangent M is 1/2, tangent N is -6, so it's M plus N. Tangent. All right, well, I'm going to rewrite tangent of M plus N using the tangent formula, which will be given to you, tan M plus tan N over 1 minus tan M, tan M, tan N. Now, it feels like this is one of those triangle problems where you need to draw your triangles and label the sides and use the Pythagorean theorem. But then I realized it's like, actually, no, they gave me what I need. Tangent M equals 1/2. Tangent M equals 1/2. I don't write tangent of 1/2. It equals 1/2. Tangent of N is -6. I don't say it's tangent of -6. The tangent of N is -6. And then over here, I have 1 minus 1/2 times -6, replacing those two things. So what's this turn into? Let's see. Oops. I don't know if that's the answer. 1/2 plus, this is -12 halves. So this is -11 halves. Adding, you don't mess with the denominators, right? It's just how many amounts of halves do you have. Here, this is 1 minus -3. So that's 1 plus 3, which is 4. So there's -11 halves divided by 4. That's a -11 halves times 1/4. Times 1/4, which is -11 eighths. Okay? That's how you do that problem. This is typically one of those triangle problems where you're given like the sine, you're given the cosine, and you have to find what the tangent of the angle is and then use that. But you didn't have to do that here. Okay, now we have something like that. Oh, fun. Okay, the question is, what is sine A plus B? Well, I need to know the sine A, cosine B, and then the cosine of A, sine B. Now I'm told A, the tangent of A is root 15. Break out a triangle, okay? Quadrant 1. Here's a triangle in quadrant 1. Tangent TOA, opposite over adjacent, is root 15 over 1. Okay, great. Now, that's A. What's the sine of A? Well, sine's opposite over hypotenuse. Well, we have to find the hypotenuse. Use the Pythagorean theorem to find the hypotenuse. I get 15 plus 1 equals C squared. So C squared's got to be equal to 4. So the sine of A is root 15 over 4. I need to find the cosine of A because I have cosine A right there. Cosine of A is 1/4. Great. Let's focus our attention on B. Well, hold on a second. You can either keep it as secant or switch it to cosine. If I switch it to cosine, I see that the cosine of B is negative 2/3. Okay, so I flipped the negative 3/2. We're located in quadrant 3, and the cosine is negative 2, that's the adjacent, over the hypotenuse thirds. Now, let's find, I have the cosine of B, that's nice, so that's there. So I can start filling stuff out. I got root 15/4, cosine of B is negative 2/3. I got the cosine of A is 1/4. Let's find the sine of angle B. Here's my angle, reference angle B. Sine opposite over hypotenuse. I'm going to have to find that. Use the Pythagorean theorem. 2 squared plus that vertical side squared equals 3 squared. So I have 9 minus 4, which is 5. So B is root 5. So the sine of B would be root 5 over 3. Okay? So this is negative 2 root 15 over 12 plus root 5 over 12. Why do they have root 60 here? Because we want to be complicated. 2 is the square root of 4. 2 times 4 times 15 is 60. 20. So it turns out 2 root 15 is just root 60. Which can be simplified as negative root 60 plus root 5 over 12. Negative root 60 plus root 5 over 12. Tricky problem, triangles, Pythagorean theorem, lots of steps using the correct formula. All right, now we got sine 2x. You'll be given this formula. This is the double angle formula for sine x plus x. You get that it's 2 sine x cos x. Okay? Sine's positive. Tangent is positive. Tangent's positive in the first and the third quadrant. Tangent's positive and sine's positive first quadrant. Careful though. Make sure you are thinking about which quadrant is my triangle. First quadrant, opposite, adjacent. I wonder if this should be 3 over 4, but it's not because okay. I need the sine of this angle x. So I need the hypotenuse. So 3 squared plus 5 squared equals c squared. So that's 9 plus 25, which is 34. So c is root 34. Should be plus or minus, but hypotenuse is always positive, and we had the correct location. So sine x, 3 over root 34. Cos x, 5 over root 34. 2 times 3 times 5 is 15 times 2, 30. Root 34 times root 34, 34. Divide the top and bottom by 2, 15/17. What? What happened? What did I do? tangent, opposite over adjacent. 9 plus 25, 34, root 34. Sine, 3 over root 34. Cosine, 5 over root 34. 5 times 2, 10 times 3, 30. Root 34 times root 34. 34. Listen, I think I'm right. Watch. And if I'm wrong, I got to go back and maybe my formula is wrong. Watch. If I take the tan inverse of 3/5, I get that angle. I think the sine of 2 times that angle is going to be 15/17. Oh, ha ha. I'm sorry. I'm sorry. That's the answer right there. I didn't have to simplify it. My bad. Freaked everybody out. Freaked myself out. But that's the right answer. All right. Never mind. Another one. Tangent is 7/2. What's the value? Okay, same thing. So be ready. Let's maybe do cos 2x in case I don't see a cos 2x. Cos 2x. Pick one of the formulas to use. If it was cos 2x, you'd have to do either cos squared x minus sine squared x, or you could do 2 cos squared x minus 1, or you could do 1 minus 2 sine squared x. They'll be given to you. All right. Let's set it up so we can do both. Between 180 and 270, boom, third quadrant. Tangent is 7/2. So here is x, opposite is 7, adjacent is 2. Hold the phone. Going in the third quadrant, I'm left and down. That needs to be negative and negative. Too many people make mistakes on that. Let's find the hypotenuse. 2 squared plus 7 squared. I don't care about the negatives because I'm squaring it. Equals c squared. That's 4 plus 49, which is 53. So this is root 53. Okay. So 2 times sine is negative 7 over root 53. It actually works out. Cosine is negative 2 over root 53. 4 times 7 is 28. Root 53 times root 53 is 50/3. 28 50/3. Boom. Okay. If I asked you to do one of these, cos 2x, probably the easiest one to do is just one of these rather than both of that. I don't think it doesn't matter. They're really all the same. Let's do 2 cos squared. Cosine is negative 2 over root 53, but that's the cosine, so square that, minus 1. So this is 2 times, this would be 4 50/3 minus 1. This would be 8 50/3 minus 1. 8 50/3 minus 53 50/3 is going to be 5. Negative 45 50/3. Okay. Do I like that it's negative? X is here, multiplied by 2. I feel like it should be positive. If I take this angle, why is it positive? Maybe my formula's wrong. Maybe this is the plus 1. No, 2 cos squared minus 1. All right, that's what it is. 270 times 2 is 540. Oh, okay. My angle actually ends up here in the third quadrant, in the second quadrant. It works out. I thought it was going to end up here if you double it, but take this angle, double it, it ends up here. Does that work out? What's 270 times 2? Isn't that going to be... Yeah, okay, cool. It's between here, and it ends up there. Anyways, we're fine. We did the correct question the correct way. All right. This is when we need to, pay attention. You might think, oh, I should square. Like, I have to solve this equation. But man, I see something right away. I kind of see, like, this in there. If I factor out a 2, I have 2 sine x cos x. Which means, like, I can replace this with that. Divide by 2, sine 2x equals root 3 over 2. Now we have one of these questions where it's like, when does sine, for what angles does sine equal root 3 over 2? Sine equals root 3 over 2 at the pi over 3's. So my angles are pi over 3 and 2 pi over 3, and then multiples of 2 pi of those, 2 pi times n. But my solutions for x, 2x would be those. My angle is 2x. So I divide both of these by 2, and this turns into pi over 6, and this turns into pi over 3. And this turns into pi n when I divide it by 2. So I get pi over 6 and pi over 3. Those are good solutions between 0 and pi over 2. Are they the correct solutions? Yeah, because if I added pi to this, I'd be at 7 pi over 6, add pi, 4 pi over 3. Okay, 2 more. Use the half angle identity. All right, so cosine of some angle over 2 equals plus or minus the square root of, it ends up coming from the cos 2 angle. Here, it's in here. There you go. Plus or minus 1 plus cos angle over 2. You'll be given this. Okay. Now, 11 pi over 12 is going to be here in the second quadrant. It's very important to realize, like, oh, the plus or minus, it's all dependent on where my angle is. Not x, but my angle, 11 pi over 12. Second quadrant, my answer is going to be negative. Okay? Now, 11 pi over 12 is the same as 11 pi over 6 divided by 2. How did I figure that out? It's like 11 pi over 12 equals x over 2. Multiply both sides by 2. And then you got 22 pi over 12, or you have 11 pi over 6. So, using this, I want 1 plus the cosine of 11 pi over 6. Cosine of 11 pi over 6 is positive root 3 over 2. You're in the fourth quadrant. You're going to the right. It's a short 30, 60, 90. So that's positive root 3 over 2. I don't see that answer. I'm going to take this, turn it into 2 over 2, and make this a 2 plus root 3 over 2 divided by 2. That's the same as multiplying by a half. So I'm going to just turn this straight into 2 plus root 3 over 4. And that's what the cosine of 11 pi over 12 is. That. negative root. Oh, look at that. It's a big root, which means it's this root in the top, and the square root of 4 on the bottom is 2. So I got a root 2 plus another root 3, negative root 2 plus root 3 over 2. That one. Half angle identity for tangent. What was the tangent? It's like 1 plus in the, no, it's the 1 minus in the top and the 1 plus in the bottom because it's the sine over cosine. Yeah, 1 minus in the top, 1 plus in the bottom. All right, so tangent of x over 2 is square root. We still have the plus or minus? I think so. Yeah, we'll have to figure out the correct plus or minus. 1 minus cosine x over 1 plus cosine x. All right, 67.5 times 2 is what I would do, which is 135. So it's 135 divided by 2. 135 is here. 67.5 is in the first quadrant. So right off the bat, I know I need a positive because we're in the first quadrant and tangent is positive in the first quadrant. Even though like 135 is in the second and the tangent value is going to be negative, I know I need a positive. Now the cosine is negative root 2 over 2 at this 45-degree reference angle. So I have the square root, the positive square root, I have a positive here, of 1 minus negative root 2 over 2 over 1 plus negative root 2 over 2, keeping track of the signs. Now that's plus a positive. I'll turn these into 2 over 2's to simplify. Giving me 2 plus root 2 over 2 divided by 2 minus root 2 over 2. Giving me, keep the top, flip the bottom, and multiply. 2's cancel. 2 plus root 2 over 2 minus root 2. All of these deserve lots of practice. I told you last class, 2 hours. You got to put in 2 hours of time towards this, at least. Do that review. If you don't understand how Mr. Schuler uses the unit circle or anything, don't worry about it. Just use your own way. Hopefully this helps you as well. Hopefully we're doing both. Hopefully you got some views here. But let's get after this test. It deserves lots of attention. Thanks. Good luck. Oh, let's see how we did. Oh, whatever. I got them all right.